In this video, we will be looking at confidence intervals, specifically the proportion version. There's two kinds of confidence intervals we're going to study, one for means and one for proportions. This will be the proportion. If you did not view the introductory video, the YouTube video with the enthusiastic teacher with the beard and the hat, then do so before watching this one. Alright, so our generic formula for confidence intervals, the generic confidence interval formula is simply statistic plus or minus some margin of error. That is, from some sample, we will have a statistic that we've gathered, and we're going to add or subtract some amount. And this is an idea that you already have good intuition about, you know. I mean, in life, if you're going to take a guess at something, you're going to say, it's 20 plus or minus a couple. That concept that you've worked with your entire life is what we're going to formalize a little bit with confidence intervals. Alright, so now we need the specific formula for confidence intervals for proportions. Alright, and it looks like this. The statistic is p hat. P hat is our sample proportion, plus or minus. The margin of error is going to have two components. One is called the critical value. And the critical value we use Z star. And this is simply a number of standard deviations. Okay. And by that we're going to multiply the standard deviation of our statistic. And it is this. It's P hat times 1 minus P hat divided by n. This hopefully looks familiar to you from our study of sampling distributions. This is very similar to the standard deviation of our sampling distribution of sample proportions. The only difference is here we've substituted p hat in place of p. We don't know what the population parameter is. We're trying to make an inference about it. So this p hat is simply the same thing here. So while this may look a little bit crazy, it's really straightforward. This p hat is a sample proportion. It's just some number we've gotten. 10 out of, in the video, he talked about tacos. All right, maybe 10 out of 25 people that you surveyed like tacos. In our area, 25 out of 25 people like tacos. But in the case of p hat, it's just some sample proportion. Z star is going to be given to us. Alright, it's a critical value, and here are three of the common ones we're going to be using. Alright, Z stars. Z star. Okay. This is our critical value. Alright, we have a critical value for a specific confidence level. Okay, so if our confidence level is 95%, that's our the one that we will use most often. Okay, the Z star is going to be 1.96. Alright, and 95% is 2 standard deviations, you may recall, so this 1.96 is very close to that. Alright, we might use 90%, and the 90% is going to be 1.645. Notice it's 90% gives us a smaller Z star to multiply by. If we're going to be 99%, that's being substantially more confident. We need a larger number to multiply by. It's going to be 2.58. Okay, I listed 95% first here because it is the one we will use most frequently. Alright, so this Z star is going to be one of these numbers. Typically it's going to be 1.96 for us. Okay, this n is simply our sample size. So we're going to be able to work some problems using this confidence interval. Alright. For this assignment, we will be working these problems, page 405 and 406, 9.34 through 9.42. Alright, let me see if I can look at one or two. Okay. I'm going to do number 9.44. 9.44 is not in your homework, but it is remarkably similar. It is like 9.34 that you have to do. So with 9.44, you should be in good shape for answering 9.34. Okay. 9.44 says, suppose a campus bookstore manager wants to know the proportion of students at the college who purchase all or some of their books online. All right, they do two different independently selected random samples, and they get two different confidence intervals. They tell us that interval 1 is 0.54 to 0.57, and they tell us interval 2 is 0.46 to 0.62. 0.46 to 0.62. All right. A says, explain how it is possible that the two intervals are not centered at the same place. Okay. Well, the reason these two intervals are not centered at the same place is they're based on a different statistic. Remember, our confidence interval is our stat plus or minus some margin of error. Okay. Thus, it's centered at the statistic. We're going to go up and down some amount we're trying to miss. So these two intervals are centered at different spots because they're based on different samples. Thus, they have different statistics. So a confidence interval is centered at the sample statistic. These two intervals are centered differently because they came from different samples. And I'm going to convert each one of these to our format, our stat plus or minus format. Okay, so again, our generic confidence interval, a confidence interval is the stat plus or minus some margin of error. I'm just going to call this ME, margin of error. So if we go from 54 to 57, what number is directly in the middle there? It's 55.5. So this confidence interval, stated another way, is 55.5 plus or minus 0.015. Okay, and you can see if I take 55.5 and add and subtract, I'll get those endpoints. This one, 46 and 62, if you add those together and divide by 2, you get 0.59, centered at 59%. And the adder subtract here, I mean to say 54. All right, that's 108 divided by 2 is 54, and the addition and subtraction is plus or minus 0.08. So this one's centered on 54%, this one's centered on 55.5. They're both close. The big difference is the margin of error. This one has a smaller margin of error, this one has a larger one. That's telling us that the sample size for this first interval is much greater. In order to get a smaller margin of error, we have to ask more people. All right, if indeed we're using the same confidence level. We'll talk more about that. But the answer on A is these things are centered in different spots because the sample, the statistic, our sample proportion was different in both of them. All right. B, which of the two intervals conveys more precise information about the value of the population proportion? Well, interval 1 does. We see it's much tighter. It goes from 54% to 57%. Its width is 3 percentage points. Here the width is 16%. So interval 1 is more precise. It has a width of 3% compared to 16% for interval 2. Okay. Next, C. C asks us, if both confidence intervals have a 95% confidence level, which confidence interval was based on the smaller sample size? How can you tell? Well, again, our confidence interval is our statistic plus or minus our margin of error. Okay, and our stat is p hat, and our margin of error is our z star times our p hat 1 minus our p hat divided by n. Well, what they're saying is here in C, if both confidence intervals have 95% confidence level, which confidence interval is based on the smaller sample size? When they tell us about our confidence level, they are giving us information about this Z star situation. Okay, Z star is our critical value, but it comes from our confidence level, and that referencing back to our initial situation here. This is Z star. It's our critical value, but we get it directly. It's going to be given based on our confidence level. The greater our confidence level, the greater this Z star. See, 95% gives 1.96, 99% 2.58. So in our problem, they're telling us that the Z star is the same, and our p hat is virtually the same. We see 0.555 and 0.54, so our p hat is very close. What must be different is n in these cases, okay? And this is in the denominator. So the larger this value n, the smaller this quotient, and we saw that in our sampling distribution problem. When we increased the sample size, we decreased the spread. So since interval 1 has a much smaller margin of error, it must have had a much greater sample size, and that makes perfect sense. The more people we ask, the greater we're going to get, the better we're going to estimate that population parameter. So for C part here, since interval 1 has a much smaller margin of error and p hat is similar and Z star identical. Okay, here's what we're saying. This number is exactly the same in both cases. These numbers are very close, so this number must have been very different. Okay, since interval 1 has a much smaller margin of error and p hat is similar and z star identical, then the sample size must have been larger. And again, this makes perfect sense. The larger the sample size, the better estimation we're going to get. Alright, D. If both confidence intervals were based on the same sample size, which interval has the higher confidence level? How can you tell? Okay, so D, they're changing up our situation. D. D. If both intervals have same sample size, compare their confidence levels. Alright, back to the formula. The confidence interval is the stat plus or minus the margin of error. Our best guess using our sample data plus or minus some margin of error. Alright, so we have again p hat plus or minus a z star times a p hat 1 minus p hat divided by n. Well, this time they're telling us n is the same. If n is the same and p hat is virtually the same, then this z star must be substantially different. Well, interval 2 has the greater margin of error. Thus, interval 2 would have to have a greater z star, so it's a greater confidence level. Again, this makes perfect sense. If these came from the same sample size, then if this margin of error is much wider, then we're much more confident we're capturing our true proportion. Think about it. If I say, I'm going to guess 55%, and I'm going to go out a couple percentage points on both sides, or I'm going to guess 55% and go out 10 percentage points on both sides, clearly the one where I said I'm going to go out wider, I'm going to be more confident. So, given that the sample size is the same, since the sample sizes are assumed to be identical, interval 2 has the higher confidence level. Interval 2 must have had a higher z star because all of these other quantities are the same, and sample 2 has a greater margin of error. Alright, with that information you should definitely be able to knock out. This was 9.44. That's remarkably similar to 9.34 for yours. Alright, let's do one more. 9.41. Okay. Says the article, students increasingly turn to credit cards, reports 37% of college freshmen and 48% of seniors carry a balance. Suppose that the reported percentages are based on random samples of 1,000 each. A. Construct and interpret a 90% confidence interval for the proportion of college freshmen who carry a credit card balance. Alright. A. construct and interpret a 90% confidence interval for freshmen. Okay, well, I'm going to begin with my generic formula. Alright, our confidence interval is a statistic plus or minus a margin of error. Margin of error. Okay, for our proportions, that is p hat plus or minus our critical value, our z star, times p hat 1 minus p hat divided by n. Okay, it says for our freshmen, 37%, that is p hat. So p hat is 0.37. That was taken directly from our sample. Plus or minus. We want the 90%. $1.645. We want the 90% z star, and that is 1.645. Directly off the first part of your notes. Referencing that again, 90% is 1.645. Alright, now p hat 0.37, 1 minus p hat, that's the complement, 0.63, divided by the square root of n. And n in this case says our sample size is 1,000. Okay, so now we have 0.37, and this just becomes some calculator work. This is 0.025. Okay, and this number here, 0.025, I hope that oftentimes when you see confidence intervals reported, particularly for percentages, you'll see that the margin for error on this poll is plus or minus 3%. This is very close to that standard that you often see, because in a solid political poll, they'll be using a sample of size 1,000, and they'll often use 95%, which will increase this, but this number is close to what you frequently see reported. So this is our confidence interval. Stated another way, it's 0.37 minus this number, which would be 0.345, 34.5% to 39.5%. And you see this is 5% wide because that's 2 times this 0.025. Okay. And it says interpret what this means. Well, here's the interpretation, and you saw this in the other video. All right. We are 90% confident the true proportion of college freshmen who carry a credit card balance lies in the interval .345 to 0.395. All right. That's the interpretation. That's the way we say it. What does it mean? Does it mean there's a 90% chance the true proportion lies in there? No, it doesn't. It means if we took these samples over and over and over again, that 9 out of 10 of them would capture whatever that true proportion is. We don't know what the true proportion is. We do know that 37% in our sample carry a credit card balance, so we just took this 37% and shot out a little bit on both sides. How much did we shoot out? Well, it was based on how close. It was based on how confident we wanted to be, and it was based on our sample size. Okay, so there it is. You have constructed your first confidence interval for proportions. With that information, you should be able to handle the rest of the problems in this assignment.